thank you for joining us. And please let me introduce you to our speaker today, Dr. Bill Curtis. Dr. Curtis is CISQ's Executive Director and Senior Vice President and Chief Scientist of CAS Software. He has led development of the Capability Maturity Model while at the Software Engineering Institute at Carnegie Mellon University. He is also the American representative for the ISO Standards Software and System Product Measures, and in 2007 he was elected a fellow of the IAOP for his career contributions to software process improvement and measurement. Thank you, Dr. Curtis, for joining us, and I'll turn it over to you.
Okay, Nicole, thank you very much. And I'm delighted to have this opportunity to speak with those of you here at IAOP. See if we can make this work. Okay, Nicole, can you see my screen?
I certainly can.
Okay, good, and everyone else can as well. So I want to talk about what you as a person managing vendors or interacting with outsourcers or other suppliers of software to your company need to do to ensure that the software you get, that the systems you get are trustworthy. And why is trustworthy important? The answer is simple. We're now in the era of 9-digit glitches. What's a 9-digit glitch? Am I talking bits or bytes? No, actually I'm talking dollars and euros. And at 9 digits, we're seeing some of these glitches cost over $100 million. Remember the Target security breach, that was estimated to cost Target around $200 million. We've seen the airlines have outages where people couldn't get on airplanes for a day because they couldn't get their tickets. Delta had one that was estimated at $140 million. The banks over in Great Britain go down constantly, and Brits can't get to their account, and in many cases some of those damages have gone well over 100 million pounds. So we're seeing these kinds of outages, these security breaches, these glitches run into the millions, sometimes hundreds of millions of dollars. In those cases, frequently the CIO loses his or her job, and in some cases the following week the CEO lost a job. So this is critical. These issues are now no longer just issues for IT or engineering. These are issues for the boardroom because of the risk that IT or products now present to the business. It becomes a huge critical issue that can affect the quarterly statement. So I'm going to talk about ways that people managing the acquisition of software intensive systems can at least do some due diligence and help manage the process so that the company is put at less risk, especially as more and more of the corporate functionality is put onto computers and you digitize and modernize the corporation. We've got to manage the risk of the systems that allow us to accomplish that. So here's an issue we have with the old time and materials contracts. A lot of people still use these, but we end up now, there's so much demand for software and software services that vendors, and we're thinking of the big outsourcers here, often end up with developers that have less than 3 years experience. I mean, we're no longer, for instance, in India, they take every kid they can get out of the Indian Institute of Technology because those are absolutely the top schools, but there's so much demand. They're down 3 and 4 tiers below that trying to find people to fill software jobs. So there's an awful lot of people that are just now getting experience with the turnover. The fact is they won't have that much experience on any particular application because they get moved to other projects or they move to other companies. So there is not a great amount of experience. We've even seen surveys where over half or 40 to 50% of the people filling out the survey said that they were self-trained. They didn't get a degree in computer science, they just grabbed a book on Java. And I guess if you can spell Java with less than 4 A's, you can claim you're a Java programmer. So we are dealing with a lot of folks who, in many cases, are doing their best, but don't really have serious depth of experience or software engineering training. And in fact, we've seen in many cases the difference between experienced and novice developers be a factor of 10x. In part, that's what they know about software engineering, But in part, that's how much they know about the application, whether they really understand what you're trying to do in finance, or what you're trying to do in telecom, or what you're trying to do in retail. You have to understand both the software engineering aspects of building an application, but just as critically, you have to understand the domain you're building the software for, so you make the right decisions about how to implement the functionality. You know, the way most people started these time and material contracts was to get labor arbitrage. They wanted a cheaper rate than they could get onshore. Well, the problem is, as there's more and more demand for developers, the fact is the prices that companies will pay to get them goes up. This is just as true in India or any of the other developing nations as it is in the U.S. or Europe. The fact is that these people will move back and forth between companies very rapidly to get a higher salary, which is driving up the cost of development. So it's reducing the labor arbitrage. And so that eventually we'll see a sort of a world rate for developers. That's decades off probably, but we are seeing a rise in those rates. So the labor arbitrage is declining somewhat. But even worse than that is the fact that in many of these organizations, we're seeing 30+% annual turnover, which means that every 2 to 3 years, you've got a whole new staff working on the application that you've outsourced, which means you're on a learning curve. And the fact is there is no labor arbitrage on a learning curve. In fact, there was a recent study coming out of Northern Europe that showed that in many cases you actually lost money by outsourcing because of the constant turnover and the constant training you had to deal with, and getting people familiar with your system and flying back and forth and what have you. So that we are seeing greater and greater challenges to the concept that the reason we outsource work is labor arbitrage, because of the changing nature of the labor force, the cost of software development, talent, and what's happening in terms of turnover and personnel issues in this industry. So time and materials is slowly dying away. I mean, if we look at the projected business value, if I'm on one end, I've got lowest business value and highest cost pressure. On the other end, I've got high business value and low cost pressure, and there's different kinds of contracts involved in each of these perspectives. The input-based contracts, the classic time and material, where I've got a fixed capacity, and there's very low incentive to get better or to produce extremely high quality software, because you're going to be paid for the amount of time you spend. And if you're spending time fixing defects, you get paid for it. So the business value here is not as great. The quality of the software is not as great. And there's a lot of cost pressure because of the amount of time being used for things that aren't as productive. For instance, fixing defects. In the middle are output-based contracts. People shift and say, look, we will pay by the amount of function points that you deliver. So we'll go out and we'll build a baseline of how many function points we think should be delivered during a period of time. We also might charge for incidents and the tickets that get produced and what have you. We might charge by the number of delivered defects. But so all of these will be a part of the way we set the rate in the contract and the value we anticipate getting based on the output, the software you produce, the quality of the software, the number of incidents that software experiences. And in some cases, people are now actually moving to true outcome-based contracts. They're a bit different because now you've got to, and more challenging, you've got to be able to define what the business value is. What service have you delivered, and at what level of quality are you continuing to deliver that service? What's the value impact on my business? How much revenue does that generate? How much cost does that save? How satisfied are we with the quality of your service? How satisfied are our customers if this is a customer-facing application? So those are going to be more challenging because you actually have to go, the business has to define the value of the service, the impact on the business, and what have you. But you can see the range here where we go from lowest to highest business value, and where we shift the cost pressure from ourselves to the contractors. Because they're now chasing high outcomes, and whatever it takes in terms of software development, software engineering to achieve that is what they have to do to get their maximum payout. Deloitte has done a recent study, and in 2014, and they were seeing roughly 50% of the contract shifting towards outcome-based contract, shifting through this progression from input to output-based on to ultimately outcome-based. And 57% of CIOs and CTOs were finding that outcome-based contracts were more effective. They actually worked better for the business because the business got higher value for the dollars, euros that they were spending on the work. More recently, ISG, and ISG, as you know, is one of the world's leading consultancies on outsourcing and guiding people and building these kinds of contracts and working relationships with outsourcers and system integrators. And this is the difference they were projecting between what they saw in 2015 and what they anticipate they'll see in 2020. And they're seeing a shift from offshore work going from 80% down to probably 60%. In essence, more and more work is being re-onshored or at least nearshored. In part, that's because as we spend more time digitizing the business, that digitization has greater value to the business, and there's a greater premium on knowing the business itself, knowing the decisions you've got to make from a business perspective about the functionality that you're building, and you need to keep that expertise in-house. That's where the expertise is, because you theoretically know more about your business than the outsourcer. You want to retain that business knowledge internally rather than give it away to someone else. So that's one of the factors driving the nearshoring, the onshoring, and that increasing trend towards bringing a lot of the work home that used to be offshore. In terms of the business model, this is shifting more of the contracting from time and materials, or augmenting the development staff from 70% down to about 50%. And it's shifting the outcome-based contracts from 30% back in 2015, now up to as much as 50% they project in 2020. And finally, in terms of key drivers, the old driver was labor arbitrage. It was cost. Or if I couldn't hire enough developers, it was being able to scale using developers from someone who basically their business is providing development skills and services. But now the focus, because we digitize more of the business, that puts the business at risk, but it also gives the business tremendous operational opportunities to improve performance, to increase revenue. And so operational excellence is critical. And when we're writing outcome-based contracts, we've got to be very careful about how we write service level agreements and key performance indicators. And those will become the drivers in the contract, especially these key performance indicators. So if we're going to do that, if we're going to really drive off key performance indicators, what do we need? How do we need to express that to make sure we get trustworthy software? In the old days, it was CMMI. We would go out and say, I want a high maturity contractor. Show me that you're a CMM level 5. Well, I can't tell you how many CIOs I visited, and since I was the fellow that led the original development of the original CMM, I wasn't involved in CMMI because that's a much bigger, rather more bloated activity. But the original CMM, which was then translated into CMMI, the CIOs, knowing that I was involved in it, say, look, what did you do? I mean, the fact is we've got this level 5 contractor and their software is so bad, sometimes it doesn't load and it blows up on us. What's the deal here? I thought level 5 meant that there wouldn't be any defects. Well, level 5 never meant there wouldn't be any defects. It just meant that they had a better process in place which would minimize the likelihood that they would have defects in their software. So the process contributes to, but doesn't guarantee high quality software, especially when some of the lead appraisers frankly didn't understand what they should be looking for when they were looking for level 4 and level 5 capabilities. They would just see a practice in place and say, okay, they're level 5. The truth of the matter is, if I want to determine your level 5, I need to see your software. I need to see, in fact, that you are producing high quality software that really doesn't have a lot of defects running around inside it. It won't be defect free. That's almost impossible to produce, but it should be dramatically better because of your quality management activities. So the process alone doesn't guarantee high quality software. It certainly doesn't measure the software itself. We need to supplement process analysis with basically measurement of the product itself. In fact, if you're looking to assess the process, I would argue if you're engaged in vendor management, you need to do your own due diligence. You need to go out and look at, if you're going to spend $100 million with an outsourcer, you need to go look at visit their site and see the practices yourself in place. You could have a lead appraiser come along with you to help guide you in the questions you should be asking. But the bottom line, you should do your own due diligence. But you need to add to that evidence that they can produce high quality products that come from the products themselves. So you need a process, you need a product focus that actually measures the quality of the code. This is a new standard with the object management group. This one in particular is on the quality of the security of the code. It evaluates security weaknesses in the code to get an assessment of how good the code is from a security perspective. I'm going to talk to you in a bit about the CISQ measures that actually measure code quality and should be a part of your tool bag if you're engaged in vendor management and managing the products that are being brought into the corporation. But you need to look at both of these now. You need to look at the process and you need to measure and evaluate the product itself. These standards, these quality measurement standards of the product were developed by the Consortium for IT Software Quality, which I'm the executive director of. We formed the consortium back in 2010, and it actually was the initial reason was that outsourcers, system integrators, were coming to the Software Engineering Institute and especially to the Object Management Group, which many of you know is an international IT standards organization. And they were approaching the leaders of those organizations, Paul Nielsen at SEI and Richard Soley at OMG, and saying, look, we need help. Our contracts are starting to include these measures for things like security and reliability and maintainability of the software, but frankly, every organization we contract with has a different definition of what that means. And frankly, we need some international standards so we don't deal with 75 different definitions. That's almost impossible. We need one we can all agree to, that's well defined so we keep the lawyers out of it, and really have something we can put in a contract with common language and a common foundation that we can all agree on up front. So CISQ was chartered to do that. We held meetings and determined if companies really wanted to join together and form these standards. They agreed on that. Originally, we had 24 companies joined at a very small sort of initiation fee. We now are run by sponsors who put up the funds required to support CISQ and its website and the outreach seminars and forums that we hold. We also have partners that we work with, IAOP being one of our best partners, but also partners like Gartner and Forrest and ITAC and others that we work with. We share information, we advertise each other's events, and what have you. So we are building a network of both sponsors and partners to help build this understanding of structural quality of software. That's the critical thing here, measuring the product itself, measuring the structural integrity of the product. So CISQ was formed to do that. We held executive forums in Washington, D.C., in Frankfurt, Germany, and in Bangalore, India, and called together executives from large IT shops and system integrators, outsourcers, and others, and said, look, if we form this, what measures would you want us to develop automated standards for. And you can see here the 5 measures they ask us to start with. First, they wanted a size measure. They wanted to measure the size of a software application using function points. They wanted that automated because they were fed up with the cost of manual counting and the inconsistency they would see between manual counters who could count the same software and come up with things that varied by 10 or 20%. So that was one goal, and they wanted us to get that as close to the counting guidelines of the International Function Point Users Groups as possible, the IFPUG counting guidelines. So that was one of our tasks. And then we also were asked to come up with automatable measures for reliability, performance, efficiency, security, and maintainability. So with the teams of experts from these 24 companies, we spent a couple of years. We now have standards for all of those measures. These are now OMG approved standards. Some of them are starting to move over to the ISO fast track, as Nicole told you earlier. I'm the American rep to the ISO 25000 series of standards, which are the standards for the measurement of software and system products. We're moving, for instance, the automated function point standard has been submitted to ISO as 19515. It has to go through their approval process. We'll be working with them to adopt or reference other CIS standards in the various ISO standards. But these are international standards supported by the Object Management Group, which is an international standards development organization. So they are available. The nice thing compared to ISO, they're free. You can go on the OMG website or the CISQ website and just download them. Now they're written in language sometimes it's hard to understand. So we have descriptions of the measures that are a little bit easier because we had to write them in a way that you could go automate them, which means there's a lot of computer language in them. Now, how did we build these structural quality standards, security, reliability, performance, efficiency, and maintainability? They were built from known weaknesses in software that affect each of those 4 quality characteristics. And we didn't include every possible weakness. You know, there's weaknesses in software. You say, you know, that's so minor, we're never going to fix it. It's not going to affect operations. It doesn't affect the cost of maintenance. It's just something we'll defer. If it's one you could defer, we don't include it. We only included weaknesses that the experts involved felt were severe enough that you had to remove them from the software in one of the future releases. These are things that you really don't want to leave in software because of their potential impact on operations or on the cost of cost of maintaining software or fixing things. So you can see examples here in the middle column there of some of these weaknesses in each of these 4 areas. So you can see the most number of weaknesses in any of these is 29 weaknesses that affect the reliability of a software system. Notice up at the top, security. That's the one area where we already had a list of the most severe weaknesses. For those of you who know the security area, you know or you've heard of the common weakness enumeration. It's a repository maintained by MITRE Corporation on behalf of the Department of Homeland Security and the National Institute of Standards and Technology. And it is a community repository of over 800 known weaknesses that hackers exploit to break into systems. And every couple of years, they review those and come up with the top 25. The 25 that are the most dangerous, those will then become the OWASP top 10 and the SANS Institute top 25. And basically there's 22 of those top 25 you can detect with static analysis. So that became the measure. And frankly, those are weaknesses like SQL injection and cross-site scripting. You want to get those out of the software. The first thing that a hacker looks for is a chance to go inject some SQL commands into a system and ask for all the data. So these are things that really have to be remediated in the code quite quickly. So we simply, the base measure in each case is a count of the number of weaknesses. You can then divide that by the function points or the lines of code or some other size measure to get a density measure that allows you to compare different applications and how dense these weaknesses are inside the software. But this gives you a good measure of the quality of the software itself. It's a product measure. And I'd like to, 2 ways I want to use this. Number one, before I make a contract, I'd like to see some examples of things they've built for other people that are like what they build for me, just to see how good they do, how good they perform. And then I want to use these in my contracts. I want to be able to say we are going to hold you accountable for the quality of your code, and here's how we're going to measure it. And the nice thing is, this is well defined. You don't have to spend hours arguing about how it's going to be measured. The measures already have been defined, and they exist, and their vendor software. Two of the major vendors that are going to support these are sponsors of CISQ. You can go see them on the list of sponsors back there on a previous slide. There's several ways then that you can engage vendors in using these measures. Number one is contact your vendor delivery leaders through email or however phone calls, however you interact with them on a regular basis, and strongly recommend that they begin using these measures in evaluating the code they're going to send to you before they send it to you for your own acceptance testing. You can include these, and we'll show you some examples in a minute of language that could be used in an RFP. You can go to the CISQ website and find some examples of this kind of language that you would use up in a request for proposal about the measures that would be used to assess the quality of what's going to be produced. In contracts, you can use these as the equivalent of a service level agreement, key performance indicator. This is how we're going to evaluate it, especially if we have penalties or credits or other kinds of rewards that can be used in the contract for delivering high quality, trustworthy systems. It can be used in a statement of work to define the quality expected of deliverables and how those deliverables will be analyzed. You can create scorecards that you can periodically discuss with vendor management, with vendor representatives about how they're doing during the course of development, how they're doing across the things that they have delivered to you. Are you seeing improvement? Are they stagnant? Or even worse, are they getting worse? You certainly don't want that. But it's something a scorecard you could use in discussing their performance on a continuing basis. And most importantly, you can use these as acceptance criteria. We will, in accepting your software, we are going to analyze it ourselves, we've got thresholds, and if you don't achieve those thresholds, you'll probably have to remediate the software at your own cost, or there'll be penalties involved in the contract. So there's a number of ways these can be used, and there's language available to you for incorporating into RFPs and SLAs and other kinds of documents. Now, deploying these kinds of measures with your vendors is not a big bang event. It's just, okay, we're using these measures, go do it. The truth of the matter is, it's a process and needs to be thought of as a deployment process. It's going to take some time to get it right. I've got 40 years experience in introducing measurement systems into large corporations. And frankly, it's not a one-month deal. When I was in one of the largest telecom companies in the world back in the 1980s, it basically took me 2 years to get a consistent software measurement system in place across the entire company so that they could all be delivering similar measures that we could benchmark and determine what our quality and productivity was across the entire corporation. And so this is a process. You introduce the process. You say, we're going to start using these. I'd like to just, based on the software we've got, start collecting some initial metrics just to see where we are, talk that over with the vendors, get them to understand what we're seeing, how we'd use these metrics, how we'd incorporate them into service level agreements, into our acceptance criteria, then start a scorecard program, and then really start using these scorecards with management early so we all get used to the idea of how these are shaping up, how they're going to be used, how we interpret them, what we would expect to be done as a result of the scores we're getting, and then ultimately introduce these into our master service agreements, our contracts, our acceptance tests, and what have you. Build them into service level agreements, into key performance indicators. And then on a second line, we want to build our own internal baselines that we can use for creating initial acceptance criteria, and that as we learn more, we'll continually update these baselines and probably update the way we use them in our service level agreements. So this is a process. It takes 1 to 2 years, but you need to start at some point and work with your various vendors and contractors to understand how you intend to measure the product itself, and use that as a major component of how you manage the contracts and the acceptance of the systems that they're delivering to you. This will increase the likelihood of getting trustworthy software the minute they know they're going to be measured. Behavior changes. You know, you've always seen that, and we'll see it forever, basically. So the truth of measure, the truth of the matter is, what gets measured gets managed. And this is a way to get a common set of measures that are international standards for this kind of use. The Government Services Administration in the United States has actually begun quoting CISQ metrics and pointing to them as ways that they will evaluate the software being delivered on contracts to the Government Services Administration. We're starting to see more and more agencies in the U.S. government. We have a major outreach with the U.S. government, both in providing comments on various requests for comment that they put out when they're thinking about updating and revising their standards for accepting software to the government, and for managing software in certain areas like high-speed trading software or software in the financial services industry. And they also are now starting to adopt this in the contracts to say, this is how we will evaluate the software we're receiving from the contractors that we have selected. And so everyone knows it's a common set of measures. Everyone understands how they're defined, and it's now in the process of being defined into these contracts and starting to set up the acceptance mechanisms for using them to evaluate the software, which means that the outsourcers, the system integrators, the contractors themselves will start using these measures internally to know that they're able to deliver to the thresholds defined in the contracts. Here's just an example of a scorecard. You can see there I've got 6 vendors, and I've got the 4 CISQ measures, and we can set threshold from red on alarming. If it's green, probably 3.3, let's say. It's sort of an arbitrary number. If it's below a 2.0, it's clearly red, because that's usually terrible software. This is on a 1 to 4 point scale. Somewhere in the 2s might be very, we're worried about it. You need to take action to bring it up to snuff. If it's in the low 3s, 3 to maybe 3.3, it's getting better. We want to see it up past 3.3, but it's not necessarily in the danger zone. So we can use this. That's just an example of how you might use it, and use thresholds, in this case on a scale of 1 to 4, which is the way one vendor does it. In addition, then, over time you can build charts that monitor the software on things like code quality, on time to repair based on the quality of the code, on productivity. If you use function points, the CISQ function point standard, you can use function points as a foundation for measuring productivity. We also have some advances on function points, frankly called automated enhancement points, that let you measure both the functional and non-functional code, so you can look at all the work done during a release to see and measure both the functional and the non-functional aspects of the release work that was done, to get a more accurate picture of the productivity. And then you can look at your own cost figures and compare that to the amount of functionality delivered to get over time, to see how your vendors are doing in terms of cost effectiveness. So this allows you to both you and the vendor look at how their performance is trending over time. Are they showing improvement? You can put some of those improvement incentives in contracts as well. But this gives you an agreed to foundation for providing this kind of measurement. So again, you don't have to spend hours arguing about it when you're developing contracts. This shows just one example, and it's just an example. You could do it different ways, of trying to put some of the contract dollars or euros at risk, as determined by the quality of the resulting code. So there'll be a base pay, but there'll also be an opportunity to earn additional money based on the quality of the delivered code. And you can set percentages, right? You can allocate a certain percentage of what you expect to pay for each application to sort of a risk reward type of a situation. You know, what is the quality of delivered in terms of security or reliability or avoidance of certain types of violations? And you can look at the multiplier for the quality of the code, get a measure of the quality of the code, and then go through the formula that allows you to determine what their reward is, or conversely, what their penalty might be. So the bottom line, if there's a default on a piece of software, they could basically forfeit the whole potential risk reward piece. And then at the annual reset, you can reset the credits and incentives. But this is one way where you could use measures like the CISQ quality measures for establishing a way to create a risk reward situation and put some of the contract money at risk for high performance. And if they give a great performance, they get a great return on their work. We also see some requirement or some request for certifications. CISQ does not certify software, but there are technology vendors. Two of those vendors are sponsors of CISQ. Synopsys with their Coverity tool and CASH with its application intelligence platform are CISQ sponsors. There are other tools that can also become CISQ conformant. CISQ has a way to go evaluate a technology to see if it does analyze the CISQ weaknesses correctly and can do the counting and actually produce accurate CISQ scores. And if they do, then CISQ will endorse that as a CISQ conformant technology. Then the technology vendor or their service providers, some technology vendors have authorized service providers that they've trained. And if they do have trained providers, then either the technology vendor or the service provider can use a CISQ conformant technology to provide a certification. Now, look, you know as well as I do, a certification based on an analysis of the software is accurate only until the first patch. I mean, the minute you patch the software, everything changes. And so I don't see this certification as a guarantee of a level of quality in the software, like you won't have certain kinds of defects. What its use is probably going to be primarily for executives who want to know at this point in time, what was the quality of our software? So I can show that I'm doing my due diligence. I am governing the risk this software presents to the business. I am determining if we need to take remedial action on a particular application because it's past our threshold for acceptable risk in security or reliability or whatever. So this really is a way for especially the executive team to say we are governing and exercising our due diligence over the risk that this software exposes the business to. So that's a possible use of this. You could even have one of your vendors provide a certificate to you that's analyzed at the point they deliver the software to you. This is the quality of the software as analyzed by such and such a CISQ conformant technology at the point we delivered this release to you. That's another possibility. So these are some resources I encourage you. I can't show you everything that's available to you in the time of a webinar, but these are sources on the CISQ website. I'll show you how to get into the CISQ website in a minute. It's free. These resources are free. We've got, with all the cybersecurity forums that we've held in Washington, D.C., we've held one in Bangalore, India, we've held one in Brussels. We'll be holding more in India and in Europe as time goes on. But this is a major source of deployment, and all of those presentations by government officials, by senior corporate executives, are on the website from each of our previous cybersecurity forums. I encourage you to go download some of those. They're very interesting. They give you sort of the state of what different organizations are doing to try to manage this challenge of increasing the amount of functionality from an agency or a business being put into software. But these resources are available to you. There's things like contract language. There's how to use these in building SLAs and other kinds of advice. Now, I keep pointing to the fact that executives need to manage the risk to the business. And all the manifestos out there, if you're in the software world, you know there's the Agile Manifesto. And some of you know there's the Rugged Software Manifesto. These are written by developers from the point of view of developers. They're from a developer perspective, and developers don't own responsibility for the risks of the business. Executives do. So CISQ has created a Trustworthy Systems Manifesto. I encourage you to read it and sign it. It's on the website, but it really is from the perspective of the business and the people who own the business risk of the software systems that run the business and the software products that the business might be selling. So the bottom line is this is what the executives should expect from either IT or engineering. And this needs to start a conversation. That's the purpose of the manifesto, is to initiate the conversation between the executive team that owns the responsibility and the risk and the folks who develop these systems. And there's basically 5 very simple principles, and we want to know how IT or engineering is addressing each of these principles to reduce the risk to the business. The first is very simple: engineering discipline in product and process. That must be primary. That is the way to manage and reduce the risk of the systems, is to have an engineering discipline that understands cyber risk, that understands what it takes to build secure systems, that understands what it takes to build reliable, maintainable systems, and performs that as regardless of the method they use, with agile development or any hybrid development, any other kind of method. What is the discipline that you will be applying that reduces the risk of that software to the business and ensures we don't have lots of security problems or reliability problems? Number 2, the executive team does need to express the risk tolerance thresholds. What is the risk the business can accept from these systems? And then I want to know what IT or engineering is doing to assure our systems work at least at those risk tolerance thresholds. Now, how do we achieve that? What are you doing to ensure that the software that we either deploy in the business or sell to our customers is able to achieve these risk tolerance thresholds, so we control and manage the risk of the systems? Number 3, frankly, all modern business systems are built as a stack of technologies, and these components are coming from a supply chain. You've got some that's open source, some is supplied by your outsourcers, there may be some from third-party vendors. There's some software that's been laying around the the company for decades, and all these are being integrated into this business application. And some of those components, especially if they're outsourced or from vendors, may have licenses that you don't know about, that you're exposed to, and that you need to make sure that you're in compliance with the license. They also may have known vulnerabilities, common vulnerability in the CVE repository, Common Vulnerability Enumeration Repository, that lists known vulnerabilities in software that's out there publicly, or this vendor software. And you need to make sure that if the application, if the open source or some of the software in this application has a known vulnerability, it's been patched, or you need to patch it right away. That caused the massive Equifax disaster, where there was a known vulnerability that wasn't patched and hackers exploited it. And of course, the cost there was a huge 9-digit glitch. So we need to understand the properties of system components. The systems you receive from your suppliers, from your outsourcers, from your system integrators need to come with a bill of materials that tell you where the components came from and what licenses or vulnerabilities you might be exposed to. Number 4, you need to engage in a proactive defense of the system and the data, and this is what we'll call a layered defense. It's not just enough to say I've protected the perimeter, our networks are secure. You actually need to remove known vulnerabilities from the software that attackers can exploit, because if they can get inside your system, they can find those weaknesses. And in fact, the Department of Homeland Security, the people in their cybersecurity division have told us the only assumption you can make that's safe is that they're already inside your system. they've already found a way in. You can't trust that they're not inside your system trying to find ways to break into your applications and get to your data. So this is a layered defense of the network, of the software, of the data. Once they're in your application, how do you protect the part that's confidential? How do you protect your customer data? So all of this becomes a very critical way to define what these defenses are and how you're protecting your systems and your data. And finally, and this is obvious, you want to create resilient and safe operations. And frankly, that has to start in the design of the applications or in the design of the products. It's hard to build that back in later. You need to make sure that you're building cyber resilient, cyber secure software, and that you're getting cyber secure, cyber resilient software from your suppliers, from your vendors, from your outsourcers. So these are some points that IT management needs to be discussing with the executive team that owns the risk and saying, this is what we're doing to solve these. These are points for executive management to be discussing with IT and engineering to make sure we're reducing the risk to the business. This manifesto is on the website. I encourage you to go read it. There's more description of each of these points. If you agree with it, sign it. Even more important, get your executives exposed to it, get your colleagues exposed to it. We really need to grow the awareness of this so we grow the awareness of what we need to do for trustworthy systems. So finally, this is the CISQ website. I encourage you to go to the website. You can see our URL up there, www.it-cisq.org. You see the nice lady there on the website. Right below her is the member button. Press that. We'll ask you a few questions, and Tracy Berardi, our program manager, will send you a password, and you're in. Membership is free. That's because we have sponsors that support the work of CISQ. If your organization would like to become a sponsor for CISQ, we'd certainly like to have you as a sponsor. But membership is for individuals, is free, and that gets you access once you're inside to the standards, to all the presentations that have been made at our various forums, to all the white papers that describe how to use the CISQ measures and contracts and SLAs. And what have you, and a number of other resources. We really want to create this as the go-to source for information on the structural quality of software and on measuring software products. In fact, we've got members from over 2,000 corporations now, over 2,000 members from lots of corporations, you can see, and these are big corporations. So we are trying to expand the CISQ outreach into the Fortune 1,000, 2,000, and really get members from IT, from engineering, from executive offices to come in and take advantage of what we are creating with CISQ. If you want more information about the things I've talked about today, and you'll be at the conference, the IAOP conference. Lev Lesokin, who is a member of the governing board of CISQ, will be giving a talk on this topic at the IAOP conference. I encourage you to go engage with Lev. He can provide you with more information and a good discussion of these kinds of issues and how you might engage them in your own vendor management work. So at this point, let me open the floor to questions. How do I get a hold of questions, Nicole?
They're in the chat box, although I just sent you the private message of a question that was put in the chat box, how to comment on gaps in manifesto, and risk does not achieve zero defects, how to find unknown vulnerabilities.
Well, certainly one way to find unknown vulnerability, if it's unknown to the world, it's going to be hard to find, but I certainly encourage you to use a suite of quality assurance techniques. It's not just standard testing. The problem with standard testing, it's mostly functional testing. And in fact, on short iterations like a Scrum sprint, mostly all people are having time for is testing functionality. That you need to, at some point there, do a static analysis, and not just at the code unit level, not just as a unit test. You need to analyze the integrated as-built software to look for interactions that represent vulnerabilities, weaknesses, problems in the way this system is going to interact. Because many of the worst defects the most serious defects, represent incorrect interaction between different components of the system. And until the system's integrated and you analyze the system as a system, you can't detect those. So there's penetration testing for trying to identify security vulnerabilities, or static analysis for structural problems. There's performance testing to look for weaknesses in the way the system performs. So there's a suite of techniques that need to be used as a quality assurance program to find as many of these vulnerabilities. There are also, if it's public software, open source, certain components of vendor software, there is the CVE repository. Those are published. You can subscribe to them, and every time a new vulnerability is identified and the owner of that software develops a patch that's announced through the CVE system, you can download the patch, apply it to your software, and be protected against that vulnerability. So there are a number of ways, and I would expect any IT shop to have a process for quality assurance, but also a process for tracking CVEs and getting those patched as quickly as possible. Other questions?
We have a comment here, if you don't mind, I'll read it really quickly,
Sure.
that there is a relationship between, excuse me, known vulnerabilities and weakness, CVEs and CWEs. CWEs are source vectors for future vulnerabilities. CWEs are the metrics used by CISQ. Zero-day vulnerabilities are often unmitigated CWEs that are detectable in software. Do you have any comments on that?
Yeah, it's true. Yeah, CWE, the CWE is a list of the weaknesses. A CVE is a weakness that has been detected in a system, and it becomes a CWE when they report it, and theoretically they identify a patch and publish the patch, so that you can identify if you have that vulnerability in one of your software components, download the patch and get it fixed. So yeah, so a CWE is a potential future CVE. CISQ measures CWEs. We're looking for weaknesses in software through static analysis to find those weaknesses. And we're not necessarily looking for every CVE. If it's a very serious CVE, and it is that means it's probably listed as a weakness, as a serious weakness that we detect. But the truth of the matter is there is software that you can acquire that does track the software you've got and compare it to the CVE weakness repository to see if there are potential patches you ought to be downloading and installing in your software. So there is commercial software available that can help you manage CVEs.
Okay, we have another question. Does risk management achieve zero defects?
No. The truth of the matter is that you talk to any computer scientist, they'll tell you theoretically it's virtually impossible to get to zero defects because it's almost impossible to know that there's not some logical glitch somewhere in the system. Our goal is to get as low as possible. That's why risk thresholds become so important. For instance, in the telecom world, they'll define how much downtime within a period, a service period, they're willing to accept. And there's a certain amount of downtime they'll accept because they know the cost of getting near zero defects is just exorbitant. So they'll tolerate a certain amount of downtime, and they'll hold their suppliers to that threshold. You've got to be able to achieve this level of uptime and not exceed it in the operational service period. If you exceed it, then there's penalties, there's liquidated damages. So the question to the supplier of telecom software is, how do I know my software can at least achieve that risk tolerance threshold, that service threshold? And I want to put together a quality assurance program that tells me I have achieved that threshold. And I can, the telecom service company is not going to provide you to exceed the threshold, but they are going to penalize you if you don't achieve it. So the truth of the matter is I need to know what the threshold is and what I need to do to make sure that my applications, my systems can, on a consistent basis, achieve the threshold. It's almost theoretically impossible to get to 0 defects.
Is there any way to ensure that a downloaded patch does not spawn another fault?
Yeah, the best thing to do is, once you've installed the patch, do a static analysis to see if there's an interaction, a discovered interaction between that newly patched component and other components, to see if it's violated something. Architectural rules, known weaknesses. Yeah, so once you've patched the software as part of your standard QA activities, you should do some kind of an analysis, probably a system level static analysis, to see if there's any interactions between that patch and other components of your software that would create a weakness.
Okay, and I believe we have time for maybe one more question, and it is, what new standards will CISQ produce this year?
We are updating the CISQ standards. The 4 quality characteristic standards I had discussed earlier were primarily designed for IT software. And with the growing impact of the Internet of Things and of software embedded in devices, especially medical devices and other devices where we need high security, high reliability software, we were asked to expand the CISQ measures to embedded systems. So for the past year, we've had a team of folks, many of whom had 30 some odd years experience in building embedded software, work on updating, basically expanding the CISQ metrics to cover both IT and embedded software. Frankly, the first thing we were told by these folks that have all this experience is that they're seeing so much functionality now being loaded onto chips that many of the same weaknesses that IT software suffered are now being suffered by embedded software because of this expanded functionality, because of all the interactions now being created through the Internet of Things. So we do have an expanded set of metrics. They're going through the OMG approval process now. If they make it through that process, I expect that by hopefully late summer, those will be published as OMG standards. Then we have a measure of technical debt, which is based on the weaknesses in the CISQ measures, where professional developers have estimated the effort required to fix those weaknesses. We have ways to adjust that based on the complexity of the code, but that then we can look at the number of weaknesses, look at the effort for each of those weaknesses, add that up across the system to get an estimate of what it would cost just in terms of remediation time for fixing the technical debt in the system. Now, you're not obviously going to do all that in one release or even probably 5 releases, but it does give you an indicator of the cost of the high severity technical debt that you need to address in your system. Sometimes those numbers are shocking to an executive, but it just means there's a lot of danger, potential severity, weaknesses in the system that need to be addressed. We will update that in the coming year to address these new expanded CISQ measures that now deal with both embedded and classic IT code. We're going to expand what's called enhancement points, which measures both the functional and non-functional software in a release. It really looks at what was changed in both functional and non-functional. We've been asked to expand that to the full system, so you can get a full system sizing of both functional and non-functional software that can be translated into something that looks like a function point. But it does measure all of the software, especially because now, in a modern business application, over half the software is non-functional, and we need to be able to measure that to get a true sizing of the software itself. I know the International Function Point Users Group has created what they call snap points to try to estimate the size of the non-functional software. What CISQ is doing is creating a measure you can take from the code to determine how big the code is in the non-functional area. So those are some of the things we'll be working on in the coming year. We're putting a lot of effort now into deploying these measures. This webinar was also one part of that, trying to make folks aware these are available and we can help you get these into your vendor management documents, into your contracts, your statements of work, your RFPs, your SLAs, and other kinds of artifacts. So with that, I assume, Nicole, we are at the end of the webinar.
We are. Thank you so much for joining us. If you have any closing comments, you can share those with us now. Otherwise, just a reminder to let everyone who is still on the webinar that I will be sending out those PDFs that Tracy mentioned earlier in the chat. Again, thank you for joining us. Bill, again, we can't thank you enough for your expertise and knowledge around this subject. We're really looking forward to seeing what else CISQ presents with us in the future.
My pleasure. Thank you.
Thank you, everyone. Have a great day.